All right, here we go. We are dealing with relationships among functions here. And so we're going to start with reciprocal relationships. And this should be something that you've seen around a little bit. It's that cosecant, what is cosecant? Well, it's 1 over sine. So cosecant of theta is 1 over sine theta. What is secant? Well, it's 1 over cosine theta, or 1 divided by cosine theta. Tangent is 1 divided by cotangent theta, cotangent of theta. Or to think of it another way, what tangent is sine of theta divided by cosine of theta. So hopefully that first block here is pretty straightforward and looks familiar. Now, part that's going to be a little less familiar is going to be this portion right here. We're going to do the second part right now as well. And this is relationships with negatives. And notice that it says sine of negative theta is equal to negative sine of theta, and then it runs through a number of relationships right here. And I want to walk you through and show you these right now. So here we go. And this is the graph of sine of theta, and I apologize that these over here got out of order. GeoGebra kept on moving them around. But this here is a graph of sine of theta. I want you to compare that to the graph of sine of negative theta, or negative x. And notice what's happened here, that all the x values, like if we'd plugged in and these are in radians here, so if we'd plugged in 1 radian, we got something right around almost 1. But if we'd plugged in a negative 1, we'd end up with something down here around negative. And so if the x values are made negative, essentially what happens for the sine graph is that that the y values are made negative. It's been reflected over the x-axis. Again, the blue one is the original graph, and it happens to be for sine. This isn't true for all functions, but for sine, that when you make the x values negative, in effect, what it does is reflects it over the x-axis. So our first one there is that sine of negative theta equals negative sine of theta. Next, cosecant, we'll deal with that one next, because cosecant and sine are very related. They're the reciprocal of one another. So let's get rid of sine here and bring up cosecant. So here's a graph of cosecant. Got the asymptotes in between here. Again, no values between -1 and 1. But this is the graph of cosecant. And so if we're going to plug in negative x in for x, what do you think is going to happen? And hopefully you're realizing that it's going to be very related to sine, where sine was made negative, was reflected over the x-axis. Cosecant also is going to be reflected over the x-axis. So here in red, we have cosecant of negative x that plugged in a 3, and the function multiplies the 3 by a -1, and then that -3, the result there, is put through the cosecant function. And so what's happened here, everything's been reflected over the y-axis in effect. There we are. Now let's next look at cosine. So to run back through, sine of negative theta gave us negative sine of theta. Cosecant of negative theta gave us negative cosecant of theta. Cosine, it looks like if we plug in negative theta, we get back just cosine of theta. And so that's interesting. Let's take a look at that one. Here is cosine of theta. And notice that it's symmetric across the y-axis, so that when we plug in values like 1, we get the exact same output at -1. So whether or not we plug in a positive x or a negative x, that value isn't going to change the result of the function. So here's cosine of negative x, and as you'll notice, it lies right on top of it. It's the same exact function. There's cosine of x and negative x. They have the exact same results. We look at secant. Secant's very related to cosine. It's the reciprocal of it. Here's secant, And notice again, it's already symmetric across the y-axis. So if we're plugging in these negative x values, our result is the exact same function. It's identical there, whether it's x or negative x for the secant function. Our last one is tangent and cotangent. So if we plug in negative theta, we get the result of negative tangent. So it's going to be similar to sine, and that hopefully that makes some sense, because remember that, well, what is tangent? It's sine over cosine. And so if the sine function, if we had plugged in a negative here and that gave us a negative sine, but cosine, when we plugged in negative theta, just gave us back cosine. Really all that's happening here is that we're getting a negative sign that's going to be pulled out in front, and there it is. So, and same thing with cotangent. Let's take a look at those. Tangent, where'd you go? There it is. There's the tangent function, tangent of x, and now we're going to do tangent of negative x, or of negative theta. And notice what's happened. It's been reflected over the x-axis. We ended up with negative tangent in essence. Same thing with cotangent. It looks like I didn't graph that one. So I'll let you just go ahead and take my word on it that cotangent is also going to just be reflected over the x-axis when we plug in a negative theta. What will happen is that we'll end up with negative cotangent of theta. All right. Now, please skip on to the fourth video in the fourth box. These items down here are going to be related, so we're going to jump to that and then go back to part number 3. But hope that helps.